Hi, Steve.
Hi there, how are you, Bruno?
Fine, and you?
Good, thank you.
Can you describe your job at Microsoft?
Yes. Can any of us describe our jobs at Microsoft?
Yeah.
So I am the Director of Program Management in the Technical Computing Organization. So I manage the program management teams across our three major areas of focus in technical computing. One area of focus we have to help developers build parallel applications. Another one we have is for developers and IT professionals building on Windows HPC Server. And another key area of focus we have that's just emerging is an effort we have to help domain specialists, scientists, engineers, financial quants in the finance space, to really be able and have access to the power of high performance and parallel computing. And so you're seeing that in some of the products we're building now in terms of HPC functionality, also in terms of products like Solver Foundation, which we have in the market as well. What program management is at Microsoft? We divide engineering into three disciplines: development, testing, and PM. The easy way to think about it is if you're not like writing code and checking it in, and you're not testing that code, then you're probably a PM, which means you're doing everything else. And really, the short version is we own the relationship with the customer in the engineering team. So it's our job to figure out, okay, well, what does the customer really want? What's important for them? What's important for the business that we're operating in? And writing the specs to describe, okay, this is how the product should work. Work with our counterparts in dev and test on refining those specs, getting the product built. We typically manage the projects as they roll along. Make sure everybody's talking to everybody, make sure we have good relationships with other teams in Microsoft that we're working with stakeholders outside of Microsoft. Kind of a catch-all type of job program management is, but it keeps us busy.
Great job. Technical computing tree, aka TC3.
Yeah, TC3.
It's a new name in Microsoft. Can you give us definition of this name?
Yeah. Well, so technical computing is really this idea that we want to harness the growing power and capacity that's in today's computer hardware, whether that is a desktop, or whether that is a server or a cluster of servers, or whether that's power in the cloud. We want to harness that power, and we want to make it available across the customers that I mentioned, across developers, across IT pros, and across domain specialists. And that's kind of where the TC3 piece comes from. So TC means technical computing, and the C3 is really a play on client, cluster, and cloud, really making computing power accessible across all the common topologies. Within technical computing, one of our goals, we find that even across all these fairly diverse customers, we find that they have a couple things in common. While your day job might be writing code, or it might be setting up a high-performance computing cluster, or it might be like trying to figure out some infection vector for some disease, all these people care deeply and require high-performance computing as a part of their job. They're trying to get the most out of the hardware, and typically the reason why they're trying to do it is often because they want to model some element of reality. They want to model the world in some way. And what we find is that these models can incorporate lots and lots of data, and they can incorporate lots and lots of computation capability. And what we find is that people's needs for both data and compute are relatively insatiable. Once you get a lot of data, then you find, wow, if I had just a little bit more, I could make my answer better. And then once you get a little bit more data, then it's like, well, now I don't have enough computation capability to handle this new data, so let me go figure out how I can bring more computation to bear on this problem to get an increasingly better model. One of the cooler things I've heard about recently, running more on supercomputer class machines, is the idea of being able to model the human heart at a cellular level, where really you have a model where kind of think about it as a mesh, where every point in the mesh is a cell. And on a petaflop class supercomputer, it takes like 1 to 2 hours to simulate a heartbeat on that kind of thing. I think we can all agree, like, over time, what we'd like to do is we'd like to make that some real-time or faster than real-time model, so that you can simulate, diseases, or simulate healthy behaviors, or whatever, what have you. But the ability to kind of increase the density of these models, and at the same time just mercilessly apply massive computing horsepower to these problems across client clusters and cloud, and including new technologies like GPU, just becomes really important, and that's the thing that ties all of our customers together.